Hello everyone, welcome to EKC 316. Today we will learn about topic number 1, which is adsorption. Alright, for this part, in this first video, we will learn about adsorption, theory and concept. Okay, actually what is adsorption? Do you know what is adsorption? And do you know what's the difference between adsorption and also absorption? Alright. In bahasa, adsorption is penjerapan, while absorption is penyerapan. Alright, for definition, adsorption is the process of capturing molecules, molecules of dissolved solids, liquids or gases. Is either one, alright? Molecule of dissolved solids, liquids or gases on the surface of certain active solids. Alright, so this component, this molecule can be separated from a mixture if it selectively adsorbs onto a solid surface. So adsorption is based on a theory that a solid surface in contact with a solution tends to accumulate a surface layer of solid molecules caused by imbalance of surface forces. Alright? However, this adsorption usually will be based on these surface forces. So there are two types of adsorption, which is one is the physical absorption, another one is chemical absorption. So in this lesson, we will look further into what is the physical absorption. Okay, there are some challenge for you if you can find out what is the difference between physical absorption and also chemical absorption. Okay, there are some example of a chemisorption, chemical absorption involving a covalent bond and ionic bond, whereas we have in physical absorption we have London forces, van der Waals, and also electrostatic forces. So in adsorption, you have adsorbent, solutes, and absorbate. Absorbent, absorbate, and solutes. You have to define and you have to know how to distinguish between these three items. What actually is adsorbent? Adsorbent is the solid which is insoluble in the liquid, and we call it as an absorbent. It is the solid which is insoluble in the liquid. Then the components being adsorbed are called solutes, which is in the liquid, and the form of adsorbate upon adsorption on the solid. So you have solutes, then once the solutes happen to be in the adsorption process, it will be called as an adsorbate. Alright? So from solute it will become adsorbate once it goes through an adsorption process. So you have absorption is a process, absorbate, solutes, and also adsorbent. There are few types of absorbent. Basically, we will classify the adsorbent into micropore. For the pore which is less than 2 nanometer, mesopore is around 2 to 50 nanometer, and macropore is more than 50 nanometer. So this is the graphical image of micro, meso, and macropore in the activated carbon. So in the activated carbon, you have the macropore, and then going into is a mesopore, a little bit smaller. Then we have micropore, which are a lot more small as compared to the other two. So the overall absorption process, a few steps. Okay, the first one, solute will diffuse through the fluid to an area near the solid particle surface. Right? So it will diffuse from the bulk of liquid into the exterior surface of the absorbent. Okay, so it's travel from liquid to the absorbent. Then it will diffuse inside the pore of this absorbent. First one, it travel to the surface, then it diffuse into the pore, and finally it will diffuse into the surface of the pore. Okay, so from liquid to the surface of adsorbent, inside the pore and surface of the pore. Let's take a look back. Yeah, it travel, okay, it travel or it diffuse, okay, diffuse from fluid to the surface, okay, then into the pore, okay, going into the pore, and finally diffuse to the surface of the pore. This is the general physical properties for adsorbent. Okay, as you can see, there are few types of adsorbent, such as granules, beads, and also small pellet. This different form came also with different sizes, as small as 0.1 millimeter to 12 millimeter, or around 1.2 centimeter. This adsorbent usually made to be porous, okay, in their structure, and also have a fine pores, okay. These fine pores actually will represent up to 50% of the volume of that adsorbent. We will take a look at a few types of adsorbent. These are the example of adsorbent. The first one, the famous one, okay, it is activated carbon. Activated carbon made by thermal decomposition of wood, vegetable shells, coals, and others. There are lots of research going to make the activated carbon. Usually the activated carbon have a surface area around 300 to 1200 meter square per gram. Okay, that's the surface of the adsorbent. Okay, its main function is to absorb organic compound. Then we have another one is silica gel. Okay, silica gel as an adsorbent, it is made by acid treatment of sodium silicate solution and also drying. Okay, the surface area of silica gel is around 600 to 800 meters square per gram, and its main function is to dehydrate gases and liquids and to fractionate hydrocarbon. So to dehydrate gases and liquids such as water, this silica gel usually can be found in your packaging. Okay, your good packaging such as shoes and etc. Okay, because its main function is to dehydrate gases and liquid such as moisture. The third one is the activated alumina. Activated alumina is made from hydrated aluminum oxide. then it is activated by heating to drive off the water. The activated alumina surface area is around 200 to 500 meters squared per gram, and it is mainly used to dry gases and liquid. So we have already take a look at 3 different absorbent: activated carbon, silica gel, and also activated alumina. So these are some of the commercialized adsorbent in the market now. Okay, you can see there are few types and few sizes of adsorbent. Okay, from 3A, 4A, 5A, and so on. From pellets, granule, powder. Okay, so these are the commercialization of adsorbent. The adsorbent also be the main topic in research. Okay, for example, there are some research on methylene blue adsorption capacity on various sorbent media. Okay, researchers try to find the function or the adsorption capacity for this adsorbent for the methylene blue adsorption. Okay, because methylene blue mainly will be recovered in textile industry. So there are graphene, rejected tea, activated clay minerals, modified activated carbon, and so on. So as you can see, there are variety of adsorption capacity, right? Ranging from 500 milligram per gram until around 16.4 milligram per gram. So this is not the updated one. Okay, this research just until 2013. So maybe in 2020 they already find another adsorbent that could cope or have a higher function or higher capacity of adsorption for this methylene blue. So there are few other questions. Okay, what are the molecular sieve zeolites, synthetic polymers, anion resin, and cation resin? Do you know what they are? Molecular sieve zeolites, polymers, anion, and cation resin? Alright. So this is your task for this lecture or for this video. Okay, this is task 1 for this video. Collect the information regarding the characteristic of listed item in previous slide, which are zeolites, synthetic polymers, anion resin, and also cation resin. Then the information should be related to the topic of adsorption. Find what are the information that relate this product with adsorption and create an infographic of your information. Okay, you've got the information, then create infographic for that information. So this assignment will be the group assignment. Only a representative of each group is needed to submit the artwork in e-learning. Okay, only one of you in your group will submit this infographic, and the group will be assigned randomly, and I already assigned a group for you. These are your group for this assignment. Okay, there are 20 teams or 20 groups, consists of 4 to 5 people, and work in a group, try to find the solution or try to develop your infographic and submit. Any group that submit twice or 2 different person in one group submit the same infographic will be penalized. Okay, so work in a group. Okay, and decide who will submit the infographic. Okay, make sure you are in your group. Okay, these are example or the real example of adsorbent inside a distillation column. Okay, this is a packed bed adsorber. Okay, these are using ring and also packing adsorber. So the general process for this column, okay, the fluid will passing through the bed, okay, then the solid particle absorb the components from the fluid until the bed will be saturated. Okay, so the process of regeneration or the desorption will occur. Then the adsorbent will be recovered. Okay, finally the bed is ready for next cycle. Okay, so the bed actually it is a place where you put all your adsorbent inside this bed. Okay, so this process adsorption will occur until your adsorbate saturated. Until your adsorbent will be saturated, then there is a regeneration to recover your adsorbent. So the question that maybe you can think during your this class is, how does saturated adsorbent regenerated or regenerate? So how can your adsorbent in your bag, okay, here in your bag, is regenerate? Okay, you can refer to internet, to your textbook, and so on. So try to find how does the saturated adsorbent regenerate. As usual, you have QR code here. Scan it and post your answer. Okay? Don't forget your name and your matric number. And this is individual work. Okay? So, after this session, you have individual work and also group work. Okay? Use this time wisely. You have 2 hours in this week or in this session. Maybe you can complete this task within a day, while another task within a week. Alright, so task 1, infographic, is due on next Thursday, while this task is due on Sunday. Okay, the second task is due on Sunday. So, don't forget your first task in introduction video, and there are 2 tasks inside this video. Okay, that's it for now, the theory and the concept of adsorption. I will see you again in adsorption equilibrium session in the next video. Goodbye and happy learning and happy discovering.